Write h cubed plus 8j to the 6th power in factored form. How do I write a polynomial in factored form? My teaching assistant Chloe is here with her latest cheat sheet notes. She wants you to know that when you are factoring, ask yourself, can you pull out a greatest common factor? And then there are 4 factoring patterns that we're going to talk about: difference of squares, perfect square trinomial, difference of cubes, and the sum of cubes. And when you are raising a power to a power, you multiply the exponents together. Now that we have Chloe's cheat sheet notes here, we can go ahead and start to factor this polynomial. So the first thing that I noticed is that in this problem, I have the h is raised to the 3rd power and the j is raised to the 6th power. Both the 3 and the 6 both have a factor of 3, so I can see that that is probably going to be a sum of cubes. So I'm going to go ahead and pretend that this is a sum of cubes and see if my answer will actually work out. So the first thing in the sum of cubes is we have a cubed plus b cubed. So I'm going to go ahead and just write a cubed plus b cubed underneath the problem, just to make sure I can understand what exactly I'm doing for each one of these. So I can see that a cubed is equal to the h cubed position. Now, if you look at my problem, I don't want an a cubed. I need an a, I need a b, I need an a squared, a b squared, and an a times b. So first of all, I'm going to go ahead and just get one a. So how do I get rid of an a cubed? I have to take the cubed root of it. Because I am taking the cube root, the cube index and the cube underneath, those would actually simplify to 1, and anything raised to the 1st power is just itself. So this side would end up being a. On the right-hand side, we have the 3 and the 3. Those would end up canceling out as well. So we would get a equals h. Now, notice how I told you we do need an a squared. So I'm already going to go ahead and just square that. A squared will be equal to h squared. Just because we take the a, which was a squared, becomes a squared, h squared would become h squared. Now let's look at our b cubed. That's the second part. B cubed is equal to 8j to the 6th power. How do I get rid of a cube? I'm going to go ahead and take the cube root of both sides. On the left-hand side, the root of 3 and the cube of 3 will end up canceling each other out. But on this one, we have some more work we have to do on this. So the first part we have here is the 8 to the cube root of 8. And you can see that when I do the cube root of 8, you're asking yourself, what number multiplied by itself 3 times, because our index is 3, equals 8? 2 times 2 is 4, 4 times 2 is 8. So 2 multiplied by itself 3 times does equal 8. And from here, we could write it as 2 cubed. And the same thing, just like what we were doing on those top ones, when you have a cube root and a cube, those can just cancel each other out. And that would just be 2 to the 1st power, which ends up reducing to 2. So when I solve this, I will have a 2 up here on the outside. But let's look at j to the 6th. We have j to the 6th, which is j times j times j times j times j times j. Our index, or our root, is 3. Therefore, we're going to make circles with 3 j's in them. How many circles did I make? I have 2. So on the outside, I'm going to have j squared. On the inside, how many did I not circle? None. And j to the 0 is the same thing as 1. So if we took a square root of 1 or the cube root of 1, it's going to be 1. Because we're pretty much asking yourself, 1 times 1 times 1 equals 1. And this cube root of 1 is just 1. So we can just go ahead and write that b will equal our 2, which is right here, j squared. Now we also need that b squared, so I can go ahead and just square that. So when we square this whole entire quantity, we have to take the square to each part. So we're going to get b squared equals 2 squared and j squared is squared. Now 2 squared we know is 4, and j squared squared, this is down here in Chloe's cheat sheet notes. When you're raising a power to a power, you multiply the exponents. J squared is being squared, so we are raising a power to a power. So we are going to go ahead and multiply those. 2 times 2 is 4. Now the next one we have to find out is the A times B. We know that A is H, so I plug in my H right here, and we know B is 2J squared. So when we go ahead and multiply those by each other, I like to put them in alphabetical order, and you should get in the habit of putting them in alphabetical order when you're combining terms. H comes before J, so my final answer would be 2HJ squared. Now I have my A, I have my B, I have my A squared, I have my B squared, I even have my A times B. What am I going to do now? I'm going to go ahead and just plug everything into this formula. So first up, I know the formula A cubed plus B cubed is equal to the quantity A plus B times the quantity of A squared minus AB plus B squared. I'm going to go ahead and plug in what I have for that. I know that I have H cubed plus 8J to the 6th, and that's equal to A plus B, so my A was H, plus my B, which is equal to 2J squared. Then I have A squared. My A squared was H squared, minus A times B, so minus 2HJ squared, plus B squared, so plus 4J to the 4th. This right here is my final answer for this problem.